Okay, how many of us remember how to do prime factorization? This was our lead-in into factoring polynomials, which is probably the most difficult unit that we had in algebra this year. So this was day one, if you recall. Very simple, but let's review it because we should. Prime factorization. Option 1, you can do a tree diagram. This is something you've been doing since probably 4th grade, so it's just a review. I have the number 60. I need to factor it. Pick any two numbers that multiplied together equals 60. If one is prime, you're looking for the one that's not prime, and you just keep making factors until all your numbers at the end of the tree are prime numbers. You list them all, and then you combine like terms. So I've got 2 times 2, 2 squared, times 3, times 5. If you make this calculation, you'll get 60. Option 2 is the ladder. I like this one. It's a little cleaner. It's a little bit easier to use. You take the number 60, you draw the box around it. Pick a number, a prime number that goes into 60. 2 goes in 30 times. Prime number. 3 goes in 10 times. 2 goes in 5. I have all prime numbers left, and I get the exact same string. 2 squared times 3 times 5 equals 60. We have something called the greatest common factor between two numbers. Here is your most basic way of figuring this out. For example, I have the numbers 64 and 16. First thing I need are the factors of 64. I could sit here and say, does 1 go into 64? Yes. Does 2 goes into 64? Yes. Does 3 go into 64? No. Does 4? And I could list every single number up to 64 if I have all day on my hands, but I don't. So what I do is I say, yes, 1 goes into 64. It's 1 times 64. So place that on the end and hope you have enough space. Does 2? Yes, 2 goes into 64. How many times? 32. Does 3? No. Does 4? Yes, 4 goes into 64 16 times. 5? 6? 7? No. 8? Yes, 8 goes in 8 times. The minute you get to the middle, you know you're done because you can't go to 9, 10. The next number you're going to come to is 16. So you're finished. 16. 1 times 16, 2 times 8, 3 times nothing, 4 times 4, you're done. Now I'm looking for the number that is the in common and the largest. 8 is common, but it is not the greatest. 16 is my greatest common factor. Now, option 2, I could do a tree or a ladder again. And this time, when I do it, I have all of my prime numbers at the end. And I sit here and I say, how many are in common? If there was a 3 involved and they both had a 3, then that would both be in common and you could use both of them. I've got 2 times 2 times 2 times 2. I have 4 of them. I have 4 here. Those are the only ones that we can count as in common. 2 to the 4th power equals 16. Just a very quick review of common factors, because when we start polynomials, we are going to be pulling out factors and lots of them. Good luck.